Hello, 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 hello. I know you've been enjoying watching my videos. For today, we want to do some magic. Chemistry has a lot of magic in it. Watch this, watch this. I'm having a colorless solution there. It looks like water. Then I'm having another one there. So what I want to do, I want to empty this one here. Wow. I'm changing water to wine. Then I'll do this one. Oh, what has happened? My wine has disappeared. No, 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 I want my wine back. Wow. Wow. It's gone and has come back now. If I empty it. Wow. That's one magic with chemistry. Chemistry. What if I have this one? And I have this one. So I want to see what will happen. I want to see what will happen. What if I do this? Look at that. Look at that. Wow. Wow. What if I empty all of it? Again, it has turned all purple. This is chemistry. Chemistry full of very many magics. Full of magics. Even this. I have two here, very colorless. Then I decide to mix. Wow. I've made something that looks so edible. That's chemistry. One of these area, or one of the areas in chemistry that has very interesting experiments to do, it's when I'm working with acid-base indicators. So for today, I want to take you through some concept, or a concept we learned in Form 1 in the Kenyan System of Education under the topic acid bases and indicators. And what we are doing today, or what I want to show you today, is the acid base indicators. The substances we use to classify other substances as either acids or bases. They are called indicators. So if somebody asks you what is an indicator, it is a substance that will assume different colors while in acid or basic solution, and it helps you to classify the substance either as an acid or a base. For today, I'll have a solution here. This is hydrochloric acid, HCl. And I have another substance here, sodium hydroxide. And in addition, I have distilled water. As we all know, distilled water is neutral in nature. It is neither acidic or basic. Hydrochloric acid, that is basically an acid. Sodium hydroxide, that's a base. It's an alkaline solution. And for today, I'm going to use three different types of indicator. I'm going to use some pieces of paper I have here, these ones, and I'm using the white space here to help contrast. I have two pieces of paper, this one. This one, it appears pink, but we call it red litmus paper. It's a red litmus paper. And this one, these are blue litmus paper. So it's a form of indicator that we are going to use for today. I have another one here. This is phenolphthalein. Phenolphthalein is another indicator. And I'm going to use another one here called the methyl orange. Okay, where do I start? I'm going to have the three substances I have here. With the first one, I'll place sodium hydroxide in a beaker. Sodium hydroxide in a beaker. That is sodium hydroxide. I'm going to have hydrochloric acid. Hydrochloric acid in the beaker. Sorry for that. In the beaker. Then finally, I'll have some distilled water. Some distilled water in another beaker. And to start with, I will start with litmus paper. This one we've said it's a red litmus paper. And we've said it appears pink, but we refer to it as a red litmus paper. The other one is blue, and I'm going to have the litmus paper, the blue litmus paper and the red litmus paper in sodium hydroxide. I will lower it in there. What exactly has happened? The red litmus paper changed to blue, or assumed a blue color. The one that was red, that is the red has changed to blue, the blue one has remained blue. That is one thing. This is not magic, it is basic chemistry. Then I'm going to have another red and a blue litmus paper. I'm going to have the two. And now for this time, I will lower it in the beaker containing the acid. No magic. The red litmus paper has remained red. The blue litmus paper has assumed the red color. Then finally, I'm going to have the litmus paper in a neutral solution, or a neutral substance, that is distilled water. And when I do that, this distilled water, I will lower them, then I will compare. The blue litmus paper has remained blue. The red litmus paper has changed to, or has remained red as in. Although we usually say with the blue litmus paper it will appear more purple, because litmus paper is purple in a neutral substance. But for this case, for now we just say it's blue. That is using the litmus paper. Now after using the litmus paper, next we try the phenolphthalein indicator. So what am I going to do? I'm going to use just the three sample solutions or substances I had. I started with the base, that is sodium hydroxide. I'll have a little sample of it. Then the next is the acid. And finally, I'll have some distilled water. So I'm going to add phenolphthalein in all of them. I'll be adding phenolphthalein to all of them. I hope you can see very clearly. Phenolphthalein indicator in alkaline solution. It has assumed the pink color. This is phenolphthalein in an alkaline solution. I'm going to introduce an acid, phenolphthalein in an acid. As you can observe clearly, it has remained very colorless. Then finally, I will add phenolphthalein in a neutral solution, or a substance that is neutral. Yep, it has remained colorless. What does that mean? Phenolphthalein is pink in an alkaline solution. It is colorless in as an acid, and again it is colorless in a neutral substance. That one we've used phenolphthalein. Next, we use the methyl orange. So I'll have a sample of the substances I'm working with. The first one is sodium hydroxide. The next I'll place an acid, just a little, and finally I'll have some distilled water. So the indicator I'm going to use, it is the methyl orange. In that order, I hope my plate there will help you contrast the colors. So with the first one, yellow in color. That one appears more yellow in color. I don't know whether, it's, yes, yellow. If you look at this part, it will tell you it is more yellow, though it's not the yellow you're expecting. It's yellow. That is, methyl orange assumes the yellow color when in a base. Then the second one is an acid. So this is methyl orange in an acid. Pink color, yes, some people can see it red. For instance, men, we don't see very many colors. So this one I can say it's pink. Someone can say it's red, and well and good. That is methyl orange in an acid, red or pink in color. Then finally I'll put methyl orange in a neutral substance. It remains orange, so it's just the same thing. That is methyl orange in a neutral substance. So in conclusion, what can we say? We started with litmus paper. Litmus paper assumes a red color when in an acid. It assumes a blue color when in a base or an alkaline solution. And it assumes purple or just remaining blue in a neutral substance. We talked about phenolphthalein. Phenolphthalein was pink, or we started with acid, it was colorless in an acid. Then it was pink when in alkaline solution. And when you placed it in a neutral substance, again it was colorless. Then we talked about methyl orange. Methyl orange indicator assumes the pink or the red color in an acid. Then it assumes the yellow color when you place it in an alkaline solution. And if you put it in a neutral solution, it remains orange. Thank you so much. This one was a good concept for the Form 1, and it cuts across because in Form 3 you need to know about the indicators you do titration. In Form 4 you have the acid, acid, base and salt. So you need to know how to classify them. Otherwise, do not forget to subscribe to this channel. Do not forget to comment. Kindly be a good student. Do not go to other sites when you have your phone. Go to Dr. Sirme Chemistry Demonstration Experiments. Thank you so much.